calculus, big topic, yeah? But you guys have been doing pretty well, I think, capturing all the different ideas. But I've been saying all along, right, that we started off slow and we're sort of gradually increasing the numbers of kinds of functions that we can deal with, differentiate, okay? So today, we're moving past trig. Well, we're not completely past it, we will keep on working with it. But we're going to introduce new function families. Now, by the way, you're like, man, it took like 3 hours just to do one trig function. And today, we're not just going to do exponentials, we're going to do logs. Are you nuts? I'm not. Well, maybe I am, but not for this reason. Exponentials and logs, they do go together, because really they're just two sides of the same coin. Okay? And I promise it will actually be very, very much quicker to derive these results. Alright? So, we'll start with exponentials, then we'll use that result, prove the log one, but it'll go like that. Okay? Now, where we're going to start with is an exponential function. Okay? So let's consider y equals 2 to the x. Okay? Y equals 2 to the x. Now, before I launch into all of the nitty-gritty technical stuff, right? Just as with trig, let's just apply some intuition to this, okay? Which is to think about, what does 2 to the x look like? What's an exponential function, right? So it starts really close to the axis and then it sort of just rockets off like so. Okay? And it's asymptotic over here. And there's your function, okay? So if you were to describe its gradient, because that's what derivatives are, right? How would you describe it? Well, number one, it's always an increasing function. I've been talking about this sort of on and off. Increasing and decreasing just means up or down. Okay? But this is, let me add another word into this, okay? This is not just increasing, it's monotonically increasing. It's like, this topic is all about long words. Monotonically means that's all it ever does. Like monotone, right? Like a person who speaks in the same tone all the time. This function is always increasing, okay? So that's why it's monotonically increasing. But it's not always increasing at the same rate. How would you describe how much it's increasing? What words would you use? Oh, snap! Okay, so let's take this idea, right? If I could represent this visually, right? Over here, I'm increasing, but I'm increasing super, super slow, right? So it's like plus a little bit, really tiny sort of increases over here. But as you get further along, you're like, okay, I'm increasing some more, and some more. And the further you go, exponentially is exactly the right word, actually, because it keeps getting steeper, and it keeps getting steeper forever. Never slows down, okay? So, just on basis of intuition, we would say this exponential function, its gradient function, also seems to be exponential. Does that make sense? It seems to follow exactly the same rules. Okay. All right. Now, do you remember with trig, right? We said we applied some intuition. What was our next step after that to try and test our intuition? What did we do? First principles. That's right. So, 2 to the x. What would it look like if we used first principles? Well, dy on dx would be equal to, how does the limit start? Oh, how does the limit start? How does first principle start? With the limit. So, spoilers. All right, what do we got on the top? F of x plus h. F of x plus h. If f is 2 to the x, what will f of x plus h be? Yeah, I'm raising that x plus h, that's my power, okay? Minus f of x, which is just this, okay? Then you divide through by h, which is the rise over run. Alright, so far so good. Now what? Got a common factor here on the numerator, right? 2 to the x here. This is actually really, 2 to the x plus h is really shorthand for 2 to the x multiplied by 2 to the h. You notice that? Remember your index laws? Okay. So therefore I'm going to take my factor of 2 to the x out. Okay, now before I do that, I'm not just going to take it out the front of the fraction. Okay? Because 2 to the x, we've done this before with trig, has nothing to do with h. Okay? I'm just going to move it completely out of the limit. Okay? So, I've got 2 to the x all the way out the front. And then, the limit, as h approaches 0, of 2 to the h minus 1. You happy with that? Okay. Now, at this point, we are rather stuck. Okay? Because that's fine, but what is this thing? What does it even look like? Okay? And that's why I brought my computer in today. Okay, I was hoping that a few of you had your computer with you and that you could actually follow along at home, and I would teach you a little bit about spreadsheets, except for you guys who are experts at spreadsheets now. But you're going to have to, since most of you do not have your laptops here, you're just going to have to settle for watching. Okay? So